knock out all of these questions here in one go. This is going to be a long video. The intention is not for you to watch it all, only to watch the parts of the video that you're having trouble with. All right, let's jump straight into it with question 1A. So we're going to expand this using the FOIL technique. The first thing times the first thing. So x times x is x squared. The outers, so x times -2 is -2x. The inners, -√3 times x is -√3x. And the last terms here, -√3 times -2 would be +2√3. Last step is really to see if you can sort of group any like terms here. There's no like terms, so I'm kind of stuck. All right, next question. A lot of people are going to get this wrong. So what I'm going to show you now is wrong. They're going to think that 2x minus 5 all squared is equal to this squared and then this squared. So they're going to say that it's like 4x squared and then -5 squared is like +25. That's totally wrong. Not going to work. 2x minus 5 all squared is simply the same as 2x minus 5 times 2x minus 5. And then you can use the FOIL method that I used above. So 2x times 2x is 4x squared. The outer terms here, 2x times -5 is -10x. The inner terms, -5 times 2x is -10x. You always get this repeated term in the middle when you do this kind of thing. And then our last term is -5 times -5 is +25. And you can always group those two like terms in the middle. So we get 4x squared minus 20x plus 25. All right, so that's an example of a perfect square. It's the square of the first one, which is that, the square of the second one, which is that, and then that times 2. It's a special pattern. So next one here is another special pattern. It's the difference of two squares. So this time we get x times x, which is equal to x squared. Now you can skip this next little bit if you know the pattern, because the outer bit is positive 4x, x times 4 is positive 4x. The inner bit is negative 4x. And so those are going to end up cancelling each other out. Continuing, -4 times +4 is -16. So they cancel each other out, and we're left with x squared minus 16. The reason it's called the difference of two squares is because there is a difference, the subtraction of a square and another square. Again, that's another pattern. Now that we've done the expanding, it's time to do the factorizing, which is the thing we just did in reverse. All right, now this one here is a special one, and you're supposed to see the pattern here. You're supposed to see this is a square, and this is a square, and it's the difference of squares. Therefore, we're going to get a nice, neat little pattern where we take the square root of 4x squared, which is 2x. We take the square root of this, which is 5, and we get 2x plus 5 and 2x minus 5. And of course, you can check your answer by expanding that, and I can guarantee you, you'll end up back where you started. Special pattern, difference of two squares. When it comes to factorizing something like this, you might have seen a few different methods. I'm going to do something called the AC method. Now, they're all boiled down to the same thing, but this is what I call it. So, we've got the A value here, the B value here, and the C value here. The beginning of the AC method is taking the A value and the C value and multiplying them together. So 5 times minus 12 is -60. Okay, and then the next bit is taking that B value, -4. And then you've got to do a bit of a puzzle here. So you've got two values, -60 and -4. And you need to find two numbers that when multiplied together make -60 and when added together make -4. A lot of people struggle with this, but you should sort of think about it a bit systematically. So looking at the multiplications here, it could be 1 and 60, it could be 2 and 30, it could be 3 and 20, it could be 4 and 15, it could be 5 and 12, it could be 6 and 10, and I think that's all of them. So looking at those, which one of them looks like if I were to add them together in some way, I would get negative 4. Now remember, I've got to put a plus and a minus in. This 6 and 10 looks promising because the difference between the two of them is 4. So 6 times 10, 6 times 10, and I need it to end up being a negative 4. Now 6 plus 10 is 16, so that's no good. But 6 plus negative 10 would be negative 4, and that there. Alright, so my two numbers are 6 and negative 10. I then use decomposition, so I leave this a value as it is, 5x squared. I decompose this b value into 6x, positive 6x, and negative 10x. And then this c value comes down as well. Okay, after that I factorize my first terms here, so common factor here of x, 5x plus 6. Now if I've done this all correctly so far, these two should also have a common factor of 5x plus 6. Sorry, not a common factor, but I should be able to take 5x plus 6 out. And then I need to ask myself, what do I multiply 5x plus 6 by to make this? And the answer is negative 2. And finally, I group this, and I get x minus 2 times 5x plus 6. Alright, that's the AC method. It's probably one of the biggest things that we do here that people get confused with. So this one is related to that last question I just did, because the first step here is to rearrange it so that it looks like 2x squared minus 3x minus 9 equals 0, and then factorize that left-hand side if you can factorize it. So I'm going to go through this one faster. If you're not sure what I'm doing here, you need to go and watch the previous question because it will make more sense. So a, b, and c values. Take the a and the c value, multiply them together. I get negative 18. Take the b value, negative 3. And I need two numbers that when multiplied together make negative 18 and when added together make negative 3. Be a bit systematic about it. 1 and 18, 2 and 9, 3 and 6. Alright, 3 and 6 looks like a good bet because I can see that 3 and 6 and there's like a difference of 3 between the two of them, so it'll probably work. A 3 goes here, a 6 goes here, a 3 goes here, a 6 goes here. I need 3 plus 6 to be negative 3, so I would need that 6 to be negative for that to be a thing. Alright, so then 2x squared, decompose negative 3x into positive 3x from there, and negative 6x from there, and a negative 9 equals 0. Common factor for the first two terms, x, and I'm left with 2x plus 3. If I've done that correctly, 2x plus 3 can be brought out over here as well. And what do I need to multiply 2x plus 3 by to make negative 6x minus 9? It looks like negative 3. That looks good so far. Bring the x together with the negative 3, and I'm left with x minus 3 and 2x plus 3. And that's equal to 0. I should really have an equal to 0 there. Okay, after that, we use something called the null factor law. So that means that if this times this is equal to 0, the only way that could be true is if the first thing is equal to 0, or the second thing is equal to 0. And then we just solve both. So if x minus 3 equals 0, that means that x equals 3. And if 2x plus 3 equals 0, that means that 2x equals negative 3, which means that x equals negative 3 on 2. They are my two answers, x equals 3 or x equals negative 3 on 2. The next question here, it's talking about a rectangle, so you should probably draw one. So we've got a rectangle that looks like this. The perimeter of a rectangle is 16 centimeters and its area is 12 centimeters squared. Calculate the length and the width of the rectangle. Alright, so I want to know what is the length, let's call it L for length, and I want to know, what is the length and what is the width. Okay, now we need to come up with some equations here. We know that perimeter is equal to length plus width plus length plus width. 2 times length plus width. 2 times length plus width. That would give me the perimeter. Now, I know what the perimeter is. The perimeter is equal to 16. So I know that 16 is equal to 2 times length plus width. And I can probably make that just a little bit simpler by dividing both sides by 2. And that means 8 is equal to length plus width. Alright, so I know that 8 equals length plus width. So maybe length is 5 and width is 3. Or maybe length is 6 and width is 2. I don't know yet. There could even be decimals. Like that could be like 5.5 and that could be 2.5. Or any other weird decimal. So I'm closer, but not that close. Alright, I know its area is 12 centimeters squared. Alright, so I know that area is equal to length times width. And in this case, I know that the area is equal to 12. Alright, so a couple of things I know now. I know that 8 equals length plus width, and I know that 12 equals length times width. What I'm dealing with here is a simultaneous equation, because I can call this equation 1, and I can call this equation 2. And if I take equation 1 and just rearrange it slightly, so if I were to say, if I were to say that length is equal to 8 minus w, I can then take that and sub it into equation 1. So let's do that. Sub 1 into 2. So that means that subbing this bit into this bit will give me 12 equals length, and then actually 12 equals, now length is equal to 8 minus w, so subbing 8 minus w into that equation for width, and then multiplied by width. Okay, so 12 equals 8 minus w times w. I can expand that. 12 equals 8 times w, which is 8w, and negative w times w, which is negative w squared. 12 equals 8w minus w squared. Okay, you can see where this is heading because that looks like the previous question. It's just a quadratic. So I can say that I can put it all on this side here. That negative w squared comes over here as w squared. That 8w comes over here as negative 8w. And we have this positive 12 there. And that's going to be equal to 0. Now, you factorize that. I'm not going to factorize it for you on camera because if you've made it this far, you should know how to factorize. And we can use our null factor law because if w minus 6 times w minus 2 equals 0, then w minus 6 equals 0 or w minus 2 equals 0. Okay, which means that width equals 6 or width equals 2. So, two answers here. Why are there two answers? Well, the equations themselves don't differentiate between length and width. If we assume that length is the longer side of a rectangle, then the width must be 2. And if we were to put 2 back into this equation, we would find, if we put width for 2 in here, we'd find that length is equal to 6. If we put width of 6 in here, we'd find that length is equal to 2. And that's sort of the opposite of what we would normally expect. So our final answer, therefore, width equals 2 and length equals 6. You could say, or width equals 6 and length equals 2, but it's generally accepted that length is longer than width. So not a lot of us are going to like completing the square, I imagine. So solving by completing the square. The first problem here is this little 2 out the front. When you complete the square, you need your a value out the front to be 1, or at least it's very helpful if it's 1. So how can I get rid of it? I can be a bit sneaky here because I can divide everything by 2. As long as I divide both sides of the equation by 2, I'm okay. If I divide the left-hand side by 2, I'll have x squared minus 2x plus 1/2. And if I divide the right-hand side by 2, 0 divided by 2 is 0. All right, so we get rid of that pesky 2 at the beginning. All right, how do we go from here? We take our b value, we halve it, and then we square it. So it's going to be x squared minus 2x. Half of negative 2 is negative 1, and then the square of negative 1 is 1. Okay, I'm going to do this in a different color because the thing I do here is a little bit strange. Plus 1, minus 1. I do this because I don't want to change the equation in any way, but it's useful to do that. And now I've got this plus half here. Okay, now that I've done that, this is where the completing the square bit comes in. Through doing that process, we can then say that this is a perfect square, and it looks like x. And then remember how we halved that b value, negative 2, to make negative 1? Negative 1 is what ends up here. Now this always works if you follow this procedure. You really don't have to actually think about it too much. You can check it though, x minus 1 squared. If you do x minus 1 times x minus 1 and you expand it, you'll get this thing right here. And then finally, this bit here just gets brought together as a single number. Negative 1 plus a half makes negative 1/2. Alright, and I have x minus 1 all squared minus a half equals 0. And now I just rearrange and solve. So x minus 1 squared equals 1/2. I can get rid of this square here by taking the square root of both sides. That's x minus 1, the square root of 1/2, plus or minus when you do a square root. And then we have with this minus 1 here, which becomes x equals 1 plus or minus the square root of 1/2. That's pretty decent. I guess if we wanted to be like really serious about this, we can say that x equals 1 plus 1 on root 2. Sorry, plus or minus. Because the square root of 1 on 2 is the same as the square root of 1 over the square root of 2, and the square root of 1 is 1. Some people might even go further and say they don't like 1 on root 2 because there's a surd as the denominator, so they might multiply top and bottom of that by root 2. If you did that, you'd have 1 plus or minus root 2 on 2. These are all good answers. All of these, 1, 2, and 3, they're the same answer. So they're all pretty good in my books. Last step here, I have a quadratic. I'm going to find the x and y intercepts. Really straightforward here. Find x-intercept, let y equal 0. Okay, so 0 equals 2x squared minus x minus 1, and then we've just got to factorize and use like a null factor law. So you've seen me factorize a bit. If you want to go and practice that, go to the exercises, but that's how you factorize that. And using the null factor law, we can say that 2x plus 1 equals 0, or x minus 1 equals 0, which means that x equals 1, or 2x equals negative 1, x equals negative 1/2. So they are my x-intercepts, negative 1/2 and 1. If I want to find my y-intercepts, which is, well, sorry, my y-intercept, I can let x equal 0, which is far, far easier. So y equals 2 times 0 squared minus 0 minus 1, y equals negative 1. Y-intercept right there. State the coordinates of the turning point and hence the axis of symmetry. If we want to find a turning point, we can use this formula, negative b on 2a. That will give me the x coordinate of the turning point. So negative b, so negative 1 over 2a. A is 2, so 2 times 2. Negative 1 is positive 1, so 1 over 4. The x coordinate and the axis of symmetry is 1/4, the x-coordinate of the turning point. Once I know the x-coordinate of the turning point, I can find the y-coordinate of the turning point by letting x equal 1/4. So y equals 2 times 1/4 squared minus 1/4 minus 1. And then I just solve that. That gives me a turning point equals 1/4 comma negative 9/8. Now I should probably mention, when I found the turning point, I used this negative b on 2a. You can also just look at the x-intercepts of 1 and negative 1/2, and you can find the middle between them. You can add them together, divide them by 2, and you'll get 1/4, which is this value right here. Because remember, quadratics, parabolas are symmetrical. Okay, finally, the question doesn't ask for it, but you could sketch this thing if you wanted to. It says that the y-coordinate is -1. Let's say that's -1. It says that the x-coordinates are -1/2 and 1. Let's say that's -1/2. And double that would be 1. So double that over here somewhere, 1. The turning points are at x equals 1/4, which means that it must be about there, 1/4. That's also our axis of symmetry. And -9/8, which is a little below -1. So maybe like here-ish. And I can label that up, 1/4 -9/8. And then do my best to draw a nice, smooth, quadratic. It's not great, but it's pretty okay. Alright, that is the full worked solution to all of those questions.